Hello everyone and welcome to Lesson 3, Neural Networks. So in this video, we're just going to go ahead and get an introduction to neural networks and understand their structure and function. So let's get right into it. Neural networks are a form of deep learning, which is classified under machine learning and AI. Neural networks were first proposed in 1944 by Warren McCulloch and Walter Pitts, though we have certainly come a long way in developing them since then. And you may have already picked it up from the name, but neural networks aim to mimic the structure of the brain, with thousands or even millions of processing nodes called neurons. So to each incoming connection, a neuron will assign a certain number called a weight. And neurons are going to receive different numbers from all of the other neurons it is connected to. And then it's going to multiply each of these numbers with the weight it corresponds to, and it's adding them up to get a final number. If this final number exceeds the neuron's threshold value, which is the minimum number that it has to be equal to or greater than to activate it, then this number will be passed on to the next neuron in the network. And this is very similar to how neuron signaling works in the human brain. Except instead of passing numbers back and forth, the neurons instead pass neurotransmitters, which are special chemicals that signal different things. And as the model adapts and improves in the training process, it's going to adjust the weights and thresholds to try and get the most accurate results. So let's check out a basic example of this in action. Let's say we're training a simple neural network to decide whether I should go to sleep. Now, I have to emphasize simple because this network just has 4 neurons, whereas, again, networks used by researchers in real-life applications can have thousands or even millions of neurons. So, some important notes. First up, a positive weight means the neuron is more likely to fire because it increases the sum, and a negative weight makes it less likely because it's going to decrease the sum. Also, the higher the absolute value of the weight, the more important that factor is in the decision. So, in case you need a refresher, the absolute value is how far away a number is from 0 on the number line. So it doesn't matter whether it's positive or negative. For example, 3 and -3 both have an absolute value of 3. And so a weight with, say, the number 100 or even -100 are much more important weights than a weight of 1 or -1. And the higher the threshold, the more contributing factors the neuron needs to activate. So again, I'm just making up numbers here so it's easier for you to understand. But let's say a neuron needs a threshold of 100 to activate. That means it's going to need a lot more contributing factors of positive numbers from the neurons behind it in order to meet that threshold. Whereas a neuron of a threshold of, say, 1 is much more likely to activate since it needs less contributing factors. And also, the neuron either activates or it doesn't. This is called the all or nothing principle, and it also is intact in brains. There's no maybe or in between or just a small amount of activation. It's only a choice of yes or no whether the neuron activates. So now that we've understood these basic principles, let's take a look at our basic network. So on the right here, we have the trained example of the network that is described on the left. So first, let's look at the setup of the nodes. So here we see we have 3 different neurons. They ask the questions, do I have to go to school the next day? Am I happy and is my energy high? And they all contribute to our neuron, which asks the question, should I go to sleep? And that's what this network is trying to answer. So let's say after we train our model and it has learned everything it needs to learn, it determines that the weights are 10, 0.01, and -5 respectively. And the threshold is greater than or equal to 5 for this final neuron to fire. So let's say that we answer these questions. So let's say that, yes, I do have to go to school the next day, which is represented by a 1. Am I happy? The answer is 0, or that basically represents no. And is my energy high? The answer is 1, or yes. And then we're going to multiply it by each of the weights. So 1 times 10 is 10. 0 times 0.01 is 0, and 1 times -5 is -5. So we add it up. 10 plus 0 plus -5, that adds up to 5. And that is greater than or equal to the threshold. So the answer is yes, we're going to go to sleep. And that means the neuron was activated. And so as we can see here, we've chosen these weights for our network because going to school the next day is the most important, right? That's why it gets a 10, because you can't exactly sleep in and you really need to wake up. Now, the question of am I happy, though it is an important question, it's not super relevant to whether you should go to sleep. So we're going to call it a 0.01. And is my energy high? The weight is a -5 because it has an inverse relationship with the final answer. So if your energy is high, yes, then probably you shouldn't go to sleep, or at least it will be harder to. And if your energy is not high or it's a no, then yes, you should go to sleep. So it's opposite and switch that way. And that's why we use a negative number. And so again, I of course wrote in these numbers and I made up these weights, but when you train the network with lots of data, it's going to come up with these weights and thresholds on its own. And we're going to have many, many layers of neurons. There's going to be so many. So it can get really, really complicated really quickly. But computers are really good at working with numbers, and so that's why they're able to come up with these numerical weights and thresholds pretty quickly. So there we go. That's a basic example of how neural networks work. And definitely we've learned a lot about them. And as you can see, neural networks are quite effective in simulating the brain. Particular network layouts, as well as rules for adjusting weights and thresholds, have actually reproduced observed features of neuroanatomy, or the anatomy of the brain, and cognition. So not only can we use neural networks to enhance our AI models and solve many real-world problems, but we can also, to some extent, understand the way our own brains work by modeling it with computers. And this, again, points to the idea that our brains are like computing devices with functions that can be scientifically described and predicted. And again, if you remember to lesson 1, video 2, where we discussed the history of AI, as AI was just being born, many different researchers had already alluded to this idea with different research in the brain structure and cybernetics and information theory. And now, by actually constructing these effective models, we've been able to prove that that is true. Pretty cool, right? Okay, so I think that concludes today's video. Let's go ahead and summarize everything we learned. So remember, neural networks are a form of deep learning, which technically also makes them machine learning and AI. Neural networks utilize a structure of weights and thresholds that connect neurons together, and it's inspired by the human brain's own anatomy. And as the neural network is trained, it adjusts the weights and thresholds to reach the optimal accuracy. And so, as it goes through many periods of trial and error, trying out and experimenting with the data, it starts to realize the patterns and determines the best weights and thresholds to get accurate results. Okay, thank you so much for watching. I hope that you learned something new in this video and that you're interested by the topic of neural networks. It's definitely really crazy to think about how we can sort of replicate structures in our brain by coding and computers. And we have a lot more research to do in this area. And if you're interested by this topic, then I'm happy to announce that our next video will be about convolutional neural networks, which are a very special type of neural network with interesting structures and applications. So if you want to learn more, I'll see you there. Bye!